You are welcome back, and we are still treating circular motion. We've looked at what will make up a circular motion, and we demonstrated. Some examples were also given. Now we want to look at the definition of circular motion. A body is said to perform circular motion when it moves along a curved path or along a circle about an axis which lies outside the body. That's the key. The key point here is that the axis or the center should lie outside the body. So key. Let me repeat the definition. A body is said to perform circular motion when it moves along a curved path or along a circle about an axis which lies outside the body. Now let's look at some applications of circular motion. Some applications. And the first one, we are looking about satellites. Now, a satellite is an instrument or it's an heavenly body, and we shall be doing this under the topic we call gravitation. So don't worry. So a satellite is a device which has been launched to move around a planet. And this satellite is moving around the planet because the satellite wants to pick information. It wants to pick some data from any part of that planet. You know what? If I have this as a planet and I have this satellite which is supposed to move around it, but the satellite fails to move around it, but it goes this way. The satellite goes this way. It just goes away from the planet. Tell me if it is possible the satellite can pick data from it. It only picks data when it is near, and it is moving away. Quite difficult for the satellite to pick information. So you see how important for the satellite to go along a circle around the planet. In other words, the satellite must perform circular motion in order to perform its job of picking data or picking signals from certain part of the planet. They wanted to know if it is possible somebody can stay on the moon. If life is possible on the moon, what they did was to launch a satellite to go around, So you see, in the use of satellites, circular motion is so key. Circular motion is so key, so that the satellite will stay around the planet and pick the data or whatever it wants. That is one use. The second use is found in the area of aviation. It's found in the area of aviation. Look, an airplane wants to land. This is the tarmac. This is the tarmac. And we have this as the airplane. And what the airplane does is to come down straight. It wants to land. It should come down straight. Come on. It hits the ground, and the impact may cause an injury. An impact may cause an accident. So what they want to do is that the plane must land on the tarmac to reduce the impact. And this is what happens. So the plane takes this path. This is the plane. The plane takes this path, take this path, take this path, and finally touches the tarmac. What has happened? It has performed the circular motion to touch the tarmac, by so doing reducing the impact. You see the usefulness of circular motion in aviation. The usefulness of circular motion in aviation. Again, in this area, in the area of an instrument we call mass spectrometer. Mass spectrometer. Circular motion is also key. As I said earlier, in an area, in a certain part of this instrument, there is a magnetic field somewhere. And this magnetic field is set in an area where an ion is sent to that area. Ion. This ion will experience a magnetic force, and therefore it will take this path, a circular path. And what happens next is that if this ion is in isotopes, if this ion is in isotopes, the isotopes will separate. The isotopes will separate. During the time that it is going along this curved path, during the time that it is performing the circular motion, the isotopes will separate. Come on, do you see it? And so, in the instrument we call mass spectrometer, circular motion helps to separate isotopes. And by so doing, you'll be able to identify how many isotopes are there in the ion. That is the area of the instrument mass spectrometer, using circular motion to be able to detect the number of isotopes there in an ion. Then we also have another area where circular motion is playing a key, and that has to do with the structure of the atom. That is the fourth area, the structure of the atom. The structure of the atom. We all know that we have the nucleus, and then we have the electrons moving. I'm asking you this question. If the electron fails to perform circular motion around the nucleus, and that electron finds its way away, moving away from the nucleus, would that constitute a unit body we call the atom? It cannot. Now, when we say an atom, the atom has a nucleus and electron together as a unit. Now, if the electron decides not to go around it and stay around it so that it can form a unit, but rather go along a straight path away from the nucleus, that will not constitute a unit body we call the atom. So you see the usefulness of circular motion. So what it means is that circular motion keeps an atom as a unit body. Circular motion keeps an atom as a unit body. And lastly, circular motion. Circular motion. That is the fifth one, right? Circular motion helps a body to change direction. Circular motion helps a body to change direction. You are in a car and you want to change your direction. The car is moving this way. You want to change and move in this direction. What will happen is that the car will have to negotiate this bend, and by so doing, performing circular motion in order to change its direction. You can see the usefulness of circular motion here. I'll come back. Bye.